Hello everyone and welcome to Tomorrow Tonight. Thanks for tuning in. Tonight we're going to talk about springs. Imagine pushing against a giant spring. Does it take effort to squash the spring? Well, it should make sense that if you push or pull on a spring, you'll feel the spring push or pull back. This is because springs exert a force on objects that stretch or compress them. Some springs are easy to compress, while others are more challenging. For example, it's a lot easier to squeeze the spring in a mechanical pencil than it is to squeeze a car spring. This difference is due to something called the spring constant. The spring constant is just a number with units of newtons per meter that represents how stiff a spring is. All springs have different spring constants, and the larger the spring constant is for a spring, the harder it is to stretch or compress that spring. So do you think mechanical pencils have a big or small spring constant? We can calculate the force a spring will push with by using the equation F spring equals Kx, where F spring is the force the spring pushes with, K is that spring constant we talked about earlier, and X is the change in length of the spring from its equilibrium or rest position. This equation is called Hooke's law. So if Wile E. Coyote compresses a spring with a spring constant of 100 newtons per meter, a distance of 2 meters, we can calculate that the spring will push back on Wile E. Coyote with a force of 200 newtons. In summary, when springs are stretched or compressed, they push back. Different springs stretch or compress different amounts based on their spring constant, which is simply a measure of how stiff or springy that spring is. Thanks for watching and see you tomorrow.